Okay, good morning everyone. Any questions? So, your homework is due this Friday, and I received one questions about the homework to get some more clarifications. I believe this was, let me check which questions it is. Yes, the question 6. Can anyone tell me actually what I am asking in these questions before I give you the clarifications? What you understand from this part? I said that regardless of your result in part 4, which is the conduct the model comparisons you outlined in 3. So it's a continuation. State your conclusions and this relevant to your output to support your this. So you are asking here that now you are interested in the effects of other variables. Here we can say weight BSA on BP. What is weight and BSA? If you go up here you can see weight we already know, and BSA here we define this one as, I think, what is the BSA? Yeah, body surface area, which is X3. So first you consider only one predictor, which is H. Now you are considering another two predictors. Yes. So what do you understand from these questions?
That we're conducting a Model C and Model A for the new predictors?
Yes. So we are now adding two more predictors in our models. Okay? In addition to the age. Age is already in our model. Okay?
Is it age?
Yeah.
Yeah.
Age is already in our model.
In the augment model, we add age, and augment model, we will add weight and BSA.
Yes, so in addition to age. So,
Yes.
so that means your augmented model is with now three predictors. Age, BSA, and weight. And what will be your compact model in this case?
Yeah.
Zero.
So you said, yeah, say loudly because the other can hear you. So my class student told me that the compact model will be, let's say if we just write it down in terms of the symbols, we can say it is y equal to beta 0 plus beta 1 x1, okay, plus epsilon. Is that right what you are saying? What do you think? Those who are online. Can you hear me? Okay. Yes. Now, is it clear? Okay. Now, over and above, these two what I use because this is what I said in class, that means your age is already in the model. Now, in addition to age, what else you can get the reduction in error by adding these two variables. That means we are interested mostly what is the additional reduction in error that we get when we add these two predictors in our models. Whether these two predictors are useful or not. If you translate in another way, whether adding these two predictors reduces PRE a lot or gives a significant reduction in error. That's what I am looking for. Is that clear? Any other questions? Thank you for asking. I think it was the tenor you asked me. Thank you asking for the clarifications. Any other question that you feel that you are not comfortable or you don't know what to do? Maybe you can go over because we have only, yes. Yes, sir. Thank you for, yeah. Okay, now.
Question 4, please.
Which one?
Question 4.
Question 4.
Hey, sir, I have a question.
This one? Sorry, what you said because I'm coming. What you said?
Can you hear me, sir?
Yes, sir.
I have a question in regards to the homework.
Yes, I am on the homework. Ask me.
Okay. So on the feedback on one of the questions I lost points from, it said that I needed to provide a table from jump.
So
as part
as
of
I
my answer.
mentioned, for example, for the homework one, if you have any questions for grading, please talk to my TA. If you cannot reach out to a conclusions, then come to me.
Yes, sir. I'm sorry.
Okay, no problem, but you can ask the TA first.
Yes, sir.
Okay, thank you for your clarifications. Okay, now you said part 4. Okay, now conduct the model comparison you outlined in 3. So this is coming from this one. So researchers suggested BP can be predicted by person A is ordered the compact and the augmented model. For this one, you know already. Yeah. Now you conduct the model comparison you outlined in this and state your conclusions. Now, how to do the model comparison? You need to use the jump, because otherwise how can you make a conclusion? Now after using the jump, you need to look at what? What you have to look for? Tell me. Anyone from the class, that's fine, because we're going to discuss it, because you already learned it. I want to make sure that you learn properly. So I already give you the hints. Fix the model by analyzing the fit model. Okay? Yes. So what next do you have to do?
You need to look at the PRE and the p-value.
You are right. That's what you have to look for. And then you make a conclusion, because that's how we can make conclusion. Always when we are comparing the model, we have two criteria, F and the PRE, and they have the same conclusions. Now this is you are comparing, keep in mind, here you are comparing simple models against the augmented model. Now your PRE is given in the jump output, because this simple model. Is that clear? Keep in mind, if you have simple models, you don't need to calculate the PRE.
R squared.
Sorry?
It's R squared, right?
Yeah, that's it. It's R square. Now, the other case, like in 6, it's not simple model. Your compact model is not simple one. That means you have to calculate the PRE. That's the only difference in 4 and 6. Any other questions before we start the new part? I appreciate your questions, because I want that you guys understand what you are doing, instead of just skim through everything. Yes.
The question 6, the
Yes.
A.
Yeah? Yes.
Define all terms is enough to just define the beta 0 and 1 and
Yes. In question 6, I ask you define all the terms. That means you just need to write what is beta 0, what is beta 1, what is beta 2, what is x1, what is x2, this and their term. This is what I mean by the define all the terms. Because whenever you are using the terms, you need to tell me that what you are using, what is this term means. Let's say if you write x1, now you need to say x1 is this, x2 is this, x3 is this, beta 0 is this, beta 1 is this, beta 2 is this, epsilon is this. Any other questions? Okay. So,
Sir, I have a question.
yes, sir.
In question 4,
Francisco, okay. Yeah.
yeah,
Go ahead.
okay, it says that online, stage your conclusions, do we have to calculate the PRE from the
Yes,
augmented?
as I mentioned that, because this one is coming from part 3. If you see that you already define your compact model and the augmented model in part 3. Now you are just doing the jump analysis, which is I gave you here, the fit the model, analyze and the fit model. After fitting the model, you need to know what is your PRE and what is your F. Now, I told you that if your simple models, like for example, if I just do it here, in this case, what is our compact model, model C? Y equal to
equals to V0
V0
plus the error.
plus the error. Okay? I say E. And the compact model, the augmented model is just adding one more predictors. Now this is, we call it, this compact model, we call it the simple models. Why we call it simple models? Because we don't have any additional predictors or additional parameters except the constant term. Now whenever you are comparing the compact model with the augmented model, if your compact model is simple, that means only the constant term, then you don't need to even calculate the PRE, because when you do the data analysis, fit the model, you will get your R square. Actually R square is PRE. This is what I said many times, so just keep in mind that in this case your R square is just simple PRE. So it's make it much easier here, because you already get your R square, and F you can get it from the ANOVA table. So and then you make a comparisons, like whether your PRE is significant or not, R square is significant, what is called F is significant or not, and you can easily see it. So you have PA minus PC is 1, because your PA is number of parameters in your augmented model, PC is number of parameters in compact model, which is 1 and 2. So 2 minus 1 is 1. And then you're going to use the table that I uploaded in A1 table, which is in the ELC, and then you make a conclusion that, okay, based on this, our p-value is this, so we can, since I didn't define that p-value, alpha, so you always use alpha equal to 5%. By default is 5%. On this, any other questions?
Yes, sir, I have another one. So the R square is the simple PRE, right? But
Yes.
the R square for the augmented model, is that correct?
Sorry, I didn't get your questions. Can you repeat it?
Of course, sir. Is the R squared from the augmented model?
Yes,
From
the PRE is the R square for this case. Yeah, you are right.
Yeah, but the R squared from the augmented or from the compact model?
Because you are only fitting the model with the augmented one, because your compact model is the mean model. Okay? So whenever you are fitting the model here, actually you are fitting the model with the predictors. So, and then you get this, because the compact model automatically comes the mean one. The mean one is the compact model, which is just a fitted line. Let's, for examples, I can show you one more time. Maybe I erase this one. Let's go back any other examples. Instead of doing the homework one, let me open the example that we did in chapter 6, the cycling data, I believe the cycling data. So in this data, if you remember that we wanted to predict the calories based on the distance, okay? So these are our simple models. We want to predict the calories based on the distance. Now, whenever you are doing that, if you use the fit models, okay, so you go to the calories here in the Y and distance here in the construct model effects. Now run the models, okay. Now what is your R square here? This is your R square. What is your simple models? Just the mean models, which is just the estimates of the effects of the mean. And if you go back here, this is the estimates of the mean, the simple models. So this is just for the compact model here, you can see, but simple model is just without this parameter. So we don't actually fit the simple models. In this case, we just fit the augmented models. And then we get the R square based on the augmented model, because R square you cannot get it for the simple models, because there is no predictors. You understand? Because whenever you have the predictors, you are comparing whether this predictors has reduction in error, or how much this predictor explain the model. If you don't have predictors, that means you are not looking at anything. You are just finding a constant term. So R square always comes with the augmented model. Is that clear? Francisco?
Yes, sir. Thank you so much.
Okay, no problem. Any other questions from anyone? Okay. No question, then we can go back. Thank you all for asking the questions and clarifying yourself for the homework. I appreciate it. And still, if you have any question, feel free to ask me before the due time. Then we can go one by one. Okay, so let's go back to our lecture notes. Okay. So if you remember in the last class, we started with the, what is called ANOVA. And in ANOVA, the main difference I told you, just the comparing the groups. Instead of checking whether if we increase 1 unit, what is the predicted value of y, but we are saying instead of increasing 1 unit, we are saying if we change one group to the other group, what is the difference in the group? So we are comparing the group means. So this is all about ANOVA that we said in the last class, and I showed you one examples here in the last class. Do you have any questions about the last class part before we move into the today's class? Now I also talked about this part, that whenever we have two categories, then it's easy because we have only one predictors, because we are comparing the two group means. Group 1 minus group 2, so we need only one predictor. Now if we have three categories, we need two predictors to compare. If we have m categories, we need m minus 1 predictors to compare the different groups. Now, the why we cannot use the t-test, I showed you in the last class that in this case, we're gonna end up with a large error rate. For example, if we just use the three categories, so we need to do 3 tests. Now, to get an error for each test is 5%. So if it is 3 tests, at least making one error is 0.143, which is much higher. We don't want to make our error large because we want to always make our error smaller. Now another thing, that if we do the 10 tests, for example, if we consider the professor ranking like this, that assistant, associate, full, then lecturer, adjunct lecturer, then we'll have 5 out of 2. That means if we do pairwise comparison, so we can see that we have 10 tests. So for each test, if there is a chance of making an error is 5%, so the probability of making at least one error, we call it the type 1 error, that means just the alpha, which is actually 0.401. So you can see that whenever we are adding more comparisons, that means more categories, the chance of making error getting larger and larger. That's the problem. We cannot make our error larger. So what we have to do, we need to reduce this error. So what is the alternative? One way we can reduce it. So this problem is called the runaway alpha or galloping alpha, because alpha is getting larger and larger whenever we are increasing the comparison. Now that's not acceptable. So what's the alternative? Alternative is that we can reduce alpha for each individual test and make the total error rate is 0.05. So we fix that, okay, this is the error rate for each test. But still, we have to do many tests, because if we have 5 categories, as for example, in our case, we have to do the 10 tests. Let's say we make our error smaller, just 5%. Just fixing for each test, okay, this is my test 1 error, this is my test 2 error, this is my test 2 error. So in overall our error size is 0.05. But still we have to make 10 tests or 3 tests. Is there any other alternative? Yes. This is what we are doing in this chapter. We are just doing the F test. Instead of doing many several tests, we are just doing one test and we are making conclusion based on one test, which is much easier. So that's why we are going to the F test. So F test, just make one single test and compare all these groups and then make a decision. And also error rate is 5%. So which is much easier. And we also look for these two, as you know that we always look for PRE and the F both. when you use the F test. Now, the thing is that how are we gonna do the test? When we are conducting the F test, what we gonna do? So we are using the contrast coded variable. Instead of using the categorical variables directly, we are looking for the contrast code. And I mentioned what is contrast last class. What is contrast? You remember? That contrast means that sum of the coefficient is equal to 0. This is called the contrast. I showed you that, okay, if we use the categorical variables, for example, the sex, I said that instead of writing male and the females, I just use some coding, numeric coding. I say that male is -1, female is 1. Why? Because if we add these two coefficients, -1 and 1, we can get 0. This is called the contrast. If you remember in the last class I showed you. Now, we are using the contrast code, but our target is to compare whether there is a difference in the group means. So for example, in our case we have 3 levels: assistant professor, associate professor, and full professor. Now, for each one we have one group. So we have group 1 mean, group 2 mean, group 3 mean. So we would like to know whether there is any difference in the group means. This is what our question is. In ANOVA we are checking whether there is any difference in the group means. Now our null hypothesis, we always assume that there is no difference in the group mean. That's why we say that mu1 equal to mu2 equal to mu3. So if I say mu1, you can say mu1 is the mean salary for professor, assistant professor, mu2 is the mean salary for associate professor, and mu3 is the mean salary for full professor. Now alternative hypothesis, in our case we are saying at least there is one differences. But we don't know which one, but we are saying at least there should be one difference. That means we can say there is a difference in the average salaries for the different groups. So if we reject our null hypothesis, that means we can say that, okay, the average salary of the different ranking has changed. Okay, there is some differences. If we don't reject the null hypothesis, we can say that knowing whether the professor are in the assistant or associate or full, it doesn't matter. Their salary is same. Okay, what do you expect? Based on our understanding, what do you expect? There should be differences. This is what we know, that if their rank change, there should be differences. So let's take it statistically. Okay. Now what is our null model? We always do the model comparison. So what is our compact model in this case? What do you think? What should be our compact model? We are saying that there is no change in the group. So it is just a simple model without any additional parameters. So we just say beta 0 plus epsilon I. Is that clear? Now when we say that, okay, there is a difference in the group means. Okay, just mean no parameters. Yes, thank you, Priyanka. Now, next thing is that when we say that augmented model. Now, first thing you have to keep in mind, how many levels do we have for the ranking? Because we are using the variable ranking, and ranking has 3 levels: assistant professor, associate professor, and full professor. If you look at this salary data, okay, because we are going to use this data set. Okay, so this is our ranking, RK. In this ranking, what is our ranking here? You can see full professor, associate, and assistant professor. We have 3 levels or 3 categories. Now, if we want to compare these 3 categories, how many variables do you need to compare the group differences? We only need 2. Okay? 2 categorical variables to make the comparison of these 3. For example, if we have only 2 categories, we only can say group 1 minus group 2. So we need only 1 variables. Is that clear? Now if we have 3 categories, we need 2 variables. So we can say group 1 minus group 2, group 2 minus group 3, that's it. Makes sense? So that's why we are saying we need only two categorical variables. So this is our model. So we use two categorical variables, and these are x1 and x2 are contrast coded. This is not our categories full professor, assistant professor or associate. We use the contrast code. So we are saying that x1 is a new variables which is a contrast code, x2 is a new variables is a contrast code. If you go back in the first example that I showed you here, so in these examples we have two categories here, male and the female. So instead of using the variables here sx, I defined a new variables x, and I said that x is a contrast coded one. Contrast code means instead of writing male, I am saying that is -1, females +1. So this is a contrast because this coefficient sum is equal to 0. So how many variables I used for this one? Only one variable. How many categories do we have? Two categories. So that's why we say that if we have two categories, we use one variable. If we have three categories, we use two variables. So in general, if we have k categories, we're gonna use k-1 variables. That's the whole idea. Is that clear for everyone? Now, here we are defining these three categories: assistant, associate, and the full. Okay? Now our variable is x1, which is one contrast code, x2 is another one. So that's why I say that xj for categorical variables is a contrast coded variables. This is not like our original labels, we are just making a contrast. So it replaced just group membership. Okay? So if we have a single categorical variables with k labels, for example, in our case, we have only one categorical variables, which is ranking. How many levels do we have? 3 levels. Ranking has assistant, associate, and full professor. Now we are saying that we need k-1 contrast coded variables. Like as in the sex, we have only one variable. We had only one variables in the sex, and we use this one as this has 2 levels. Male and female. But I used only one contrast coded variables, which I say x, which is equal to -1 and +1. So only one variable. Now I have variables which is rank. So I say rank R, okay. And this has 3 levels. One is assistant, another one is associate, and other one is full. So 3 levels, so we need 2 variables. So that's why I am saying x1 and x2. That's the whole idea. Now we need to define what is our x1 and x2. So that means we need to define 2 contrasts. Now by definition we know that contrast should be defined in such a way that the sum of the coefficient should be equal to 0. That's the whole idea. Okay? Now there is when we have more than one variable, so we need another important rule, that one thing that we say that sum of the coefficient should be 0. Another one we say that sum of the product of the coefficient should be equal to 0. So we make it orthogonal contrast. So for examples, if you go back here, maybe I can just erase this one. So look at these two, because we need 2 contrasts. We know why, because we have 3 categories. So I defined here good one and the bad one. So look at the first one. So I have 3 groups: group 1, group 2, group 3. What is group 1? Assistant professor. Group 2, associate, full professor. So we have 3 groups, yeah? Now I am defining 2 variables by using the contrast code. Now you can see for the first variables, So lambda 1 is the contrast code for the first variables for x1. So this is, you can say, contrast code for x1. So lambda 1 is the contrast code for x1. Now, when you have single variables, we just define 1 and negative 1, that becomes a contrast. Now we have two variables. So I am defining the contrast code for x1 is like this. Okay, 1, negative, half, and another one, negative half. Now if you add all these three, what are you going to get? If you add all these three, you get 0. Am I right? Now you get 0, that means this is a contrast. Now same thing, if you add all these three coefficients for lambda 2, you're going to end up with the 0. So that defines the contrast. This is rule 1. This is what I said, that sum of the coefficient for a given contrast must be equal to 0. So this is 0. Now look at the second rule. Second rule says that to test all possible differences, all contrast must be orthogonal. So what does the orthogonal means? I define this up. Lambda 1k times lambda 2k should be equal to 0. So in our case it is 1 times 0. So this is one part, plus half times 1 plus negative half time 1. What do you think? This sum equal to what? 0. Is that clear? Because if you multiply these two, it is this. 1 times 0 is 0. Negative half times 1, which is negative half. And this one is negative half. So you're going to end up with what? Sum of the coefficient, sorry, this is negative 1. So sum of the coefficient, this will be half, this will be negative half, so this is going to be 0. So this is what we mean by sum of the coefficients, or we call it the dot product, which is equal to 0. Right, sense? Or any questions before I move into the next part? Okay, so if you don't have, so that's what the idea here that I'm going to use. Okay, now I said that this one is bad. Why I said this one is bad? Do you see what's wrong here? Is it contrast? Lambda 1 is a contrast or not? Can you tell me, is lambda 1 is contrast? Yes, it's a contrast. What about lambda 2? It's a contrast, because some of the coefficients are 0. But if we take the product of these two coefficients, can we get 0? So if we multiply, for example, negative 1 to 0 plus 2 to 1, so we get here 0, this is 2, this is 2. So the sum of the coefficient is not 0. So that means this does not satisfy rule 2. So that's why we say that this is not an orthogonal contrast, this is just a contrast. But we also want to make sure this contrast is orthogonal. And this is what we mean by the orthogonal contrast. So that's why I said that this is good, this is not good. This does not satisfy our conditions. Now there are different ways of defining this contrast. There is no single one rules that we can define the contrast, but there are many different ways. One of the most popular one is the Helmholtz contrast. Now, how can we define this Helmholtz contrast? I'll just show you here. So this is the general rule for the Helmholtz contrast, and we're gonna use this one. But you can choose your own contrast. I'll show you both. But first of all, look at the Helmholtz contrast. So for example, if we have M categories, this is from your book actually. If we have M categories, so this is what we said, that category level 1, 2, 3, M minus 1, M here. Now lambda 1k, will be starting from m minus 1, then negative 1, negative 1 until all negative 1. So for examples, in our case, how many m equal to, in our case, what is our m? How many labels do we have? 3. Okay. Now if I want to define the orthogonal contrast, so we should say lambda 1. If I use the Helmholtz contrast, what will be our contrast code for lambda 1? Can anyone tell me? M equal to 3. So the lambda 1, which is our first variable, first orthogonal, so first contrast, what should be a lambda 1? M minus 1, which is 2. Okay. Next one, negative 1. Next one, negative 1. Okay. Now we need another one, lambda 2. What will be our lambda 2? So we start with the 0. Next one, 1, because m minus 2 is 1. And the next one, negative 1. So this will be my orthogonal contrast. And you can see this is orthogonal contrast because if we take the sum of these 3, which is 0. Sum is 0. These 3, sum is 0. Now if we take the product of this, so 2 times 0, then negative 1 times 1, so we can just write it down this. Then the other one, negative 1 times negative 1. If we add all these 3, this is 0, this is negative 1, and this is 1. So we get 0. So it satisfied all these conditions. So these are the two conditions. We can see that some of the coefficients are 0 and some of the product of the coefficients are also 0. So this is an orthogonal contrast, but this is a nicer way. So you don't need to worry how I can make it sum is 0 and some of the coefficient is 0. You just follow these rules. And this is called the Helmholtz contrast. Any questions? Okay. Now the question is that how can we do it? So let's consider our case. This is the general case that I just defined. Now in our case we have 3 groups for the Cellery data set, and we are we are only considering the variable which is the rank. So we had contrast code, meaning that we have 2 predictors, x1 and x2, and we can record this as rank 2 and rank 3 to distinguish from the original variables. But how can we record it? So let's go back. So this is our rank variables. Okay, if you want to record it, you know how to record it. Select, calls, what is the record, and the record. Okay. Now you can give any name. Okay. Now, what you have to start? So I said that here, if you go back, where is my lecture notes? Yes. So I said that we can do the 2 contrast to distinguish it from the RK, and once for new contrast, and then I use the Helmholtz contrast for these variables in the order assistant, associate, and the full professor. So what is Helmholtz contrast? We just defined, which is for this one it will be 2, negative 1, and 1. Is that right? So 2 is what? 2 for which rank? Assistant professor, then associate professor. So let me just write it down here. So 2, which is for the assistant, negative 1, associate, I just say A, and another negative 1 is for full. So you need to define this. Okay. Now let's go back and do it in this data set. So we go to this recording. Sorry. Now how can you redefine this on? So assistant, what do you have to put? 2. So I put 2. Associate, what do you have to put? -1. So I put -1. Full? -1. Okay. So this is what I am using the contrast code for this. And then click recode. So since I put the name as rank 4 to rank 4, so where is the rank 4 here? And now you can see that it's recorded. Full professor is -1, associate professor is -1, and assistant professor is 2. Now this is one variable that we created, which is x1. Now we need to also do another variable, which is x2. What is our x2? Let's go back to lecture notes. What should be our x2? What should be our ranking?
0,
Okay.
1, 5.
So in this case, this will be our 0, which is our assistant professor. 1 will be our associate professor. -1 will be our full professor. So this will be our 3 ranking. So let's do it in the jump. So we go to the again the rank. Here this one. False. Record this one. Now this will create another variable which is rank 5. So this one is what? 0. So I put 0 here. Associate is 1. I put 1 here. And full professor is what? -1. So I put -1. So I recorded this. So you can see that there is another variables. Maybe I can just remove this one. So you are not confused what this one is coming here. So you recorded these 2 variables. Rank 4, that you just got it beginning, that rank 4 is your x1, rank 5 is your x2. Is that clear? So this is how I recorded it. So that means we use the Helmholtz contrast to create the 2 variables. So look at this. We have originally only one categorical variables, which is rank. Now this rank has 3 categories: assistant professor, associate professor, and full professor. Now if we have 3 categories, so we can create 2 contrast. Okay, so 2 contrast coded variables. In this case, if we say x1 and x2, here rank 4 is our x1, rank 5 is our x2. Does it make sense? Okay. Now we did this part.
So I have a
This is
question.
what actually is given. So here I said that rank 2 and rank 3 because I already created but I wanted to show you, so I created another 2 variables. If you go back to this data set, you can already see that we have these rank variables here, rank 2 and the rank 3. This I already created, but I wanted to show you one more time, so I created the 2 variables here in these 2 columns. And make sure I say that you just make it numeric. So look at these 2 variables that I created. How do you know that this is numeric or not? If you look at this here. So rank 4 is categorical. So we can make it numeric, if you just right click on this, or you can anywhere you can right click on this. Sorry. Column info and numeric and continuous. The same thing for the rank 5. Right click on this. Sorry. Why is there? Right click on the variables, select the column info and change it to the numeric and continuous. This is what I said that you're gonna change it. Okay. Now you can see that there is a triangle beside the variable name, so this is means continuous. So this is what I say, that I use the Helmut contrast for these variables in the order assistant associated in the full professor for the ranks. And when you do this, you must be sure to format the newly recorded variables as numeric and the continuous. We just did it. Now come back to our models. So how much time we have? We have only 2 minutes. Now, model C, what is the model C? Based on our null hypothesis is that there is no difference among the group means. So mu1 equal to mu2 equal to mu3. That means this is just a simple models without any predictors. So we say beta 0 equal to 0. Sorry, beta 0 plus epsilon I. Now augmented model here, augmented model is beta 0 plus beta 1 xi1. So which is our first contrast coded variables, you can say rank 4, and beta 2 xi2 which is the rank 5. So we can create the two variables. Okay. Now what we are looking for, we are comparing the group means. So I said here the beta 1, this is the difference between group 1 and the average of the other two groups. And beta 2 is the difference between group 2 and the group 3. Okay? And you can calculate all these betas by using this formula, and I will show you, because today I cannot show you. So I will show you how we can calculate this one in the next class. Okay? We're gonna go over more details about this part and all this output here, how we get this. So please look at all these outputs, how I get it before coming to the class, and hopefully I'll do it in the next class. And we're gonna finish this chapter, hopefully. But I am trying to go very slowly, so you get it with me and everything should be fine. Any questions so far? Okay, let me see. Will you please re-explain how to read the Helmut tables? Yes, thank you, Charles. So go up. So Helmut tables. Maybe I can go a little bit faster here. So this is a Helmut table. So you can see m minus 1. So that says that we have m categories. So in our case, our m is equal to 3 because we have 3 categories. So first variable that I consider lambda 1, the contrast code m minus 1 is actually 2. Okay. Now next one is 3 minus 1, sorry, minus 1, so I put minus 1, and next one is minus 1. So this is for the lambda 1, and similarly for lambda 2, you get the contrast code like this. So 0, it's from the Helmut contrast, then m minus 2, so our m is 3, so m minus 2 is 1, and then 1, which is negative 1, so we just put it like this. So that's how we get this two contrast code using the Helmut contrast. Is that clear, Charles? Yeah. Okay. Any other questions? Okay, so if you don't have any question, then I can end the meeting, and please let me know if you have any questions. Okay. Thank you all, and see you on Friday.
Dr. Chaudhary,
Yes.
do you have like a pen that you can write with on the screen? I've seen some of my other professors have